Hello, everyone. My name is Scott Grizzard from the University of South Florida. This is Calculus Fall 2020. We're going over quiz 11B. If you weren't in chat, you didn't hear me say all sorts of embarrassing political things that could get me fired. So, sorry. Show up for chat sometime. Anyway, there is chat, of course, in Twitch. There's chat, of course, in Blackboard Collaborate Ultra. Polls will be in Blackboard Collaborate Ultra, and Blackboard Collaborate Ultra is private, and Twitch is public. Okay, so let's get down to this quiz. All right. The Renaissance Fair wishes to set up a rectangular area for employee parking, needing a space of 300 square feet. Okay, so I've got something going on with a rectangle. I'm going to draw this out a little bit. And I know the area of the thing is 300 square feet. Okay. 3 sides will be visible to patrons. That one, and that one. The north side, okay, so the north side cannot be seen. So this is going to be cheap fence. This is going to be themed. This is going to be themed. And this one's going to be themed. This stuff is half as expensive. What's the least expensive way to set up the parking lot? Okay. So how do we feel about what I've written there, 1 to 5? Let's see. Polling, multiple choice. Okay, is it working now? Okay. Sorry about that. I didn't activate the camera thing on Blackboard Collaborate Ultra. I was only on Twitch. So that's kind of the setup idea. Now, a common mistake, and I should have mentioned this on the video when I talked about it. A common mistake is to assign your variables too early. Don't do that. Okay? So you look at this theme fence, and your temptation is to go X, 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 Y. And that's actually not the way you want to set this up, right? So, common mistake, assigning variables too early. Usually what you need to do is you need to figure out what you're producing. Here you're producing area. So, as I said, so identify what you are producing. So here what I'm producing is area. How do we feel about that 1 to 5? So what I'm actually creating is area. Okay. So what you want to do is you usually want to do your variables off the thing you're producing. Okay? So I'm producing area. I want 300 square feet of area. That's the thing that's producing, and it costs me my perimeter type thing here, right? It's going to cost me one of these plus one of these plus one of these plus half of that. Okay? So, in identifying what I'm producing, if I identify what I'm producing area. So I'm going to write down those equations. Area equals width times length. So what I'm going to do now is I'm going to stick my variables on here. I'm going to have W here, W here, L here, and L here, because my area is length times W. And my cost equation here is, and again, cost and the thing you're producing for output does not need to be, it can be area, it can be volume in a can, it can be all of these other things. And, everything costs something, but it's not necessarily money, right? Here it costs me whatever my resources is. The question is, how do I use that configuration of resources to find the optimum? So if I look at this with some intuition, it looks like W, which costs half as much on top, should be wider. This thing should be wider than it is kind of tall. Okay? So my intuition leads me to believe that W should be greater than L. Okay? So 1 to 5, how do we kind of feel about, the feel of the problem? Because that's a big part of these things, is kind of, what's kind of going on, what should be, what's the intuition? W should probably be bigger than L. Because one of the walls is half as much. I mean, I could make, one of the problems that's common is to, we make one of the walls free, right? If I had made, let's say I wanted Trump to pay for the top wall, Canada pays for that wall, whatever. Then I should expect my width to be much bigger than my lengths. Same thing. I had to get the Trump pays for the wall joke in there somewhere, though, so, So let's see what's going to happen. So I've got the cost, whatever it is going to be L plus W plus 1/2 of W. Okay? And then one of these is fixed. The area is fixed at 300. Okay. So what I'm going to do now is I'm going to solve for one of my variables. So solve. So these are my equations. And then I want to I want to minimize C given A. Okay? So what am I going to do here? Well, I'm going to solve for, solving for one of the variables. We'll call this process solve and sub, I guess. Are there any questions? I don't see any questions in the chat. I just see, people commenting. Okay, so this kind of solve and sub bit. I've got W times L equals 300. And that's going to mean that, pick L, who cares? L equals 300 over W. Okay, so now I'm going to sub that in here, and I'm going to get C equals 300W over W plus 300 over W plus W plus W over 2. Okay, so how do we feel about that kind of solve and sub thing? Okay. All right. And then I need to kind of reason endpoints. Okay, well, As W gets bigger, C is going to shoot off to infinity, and same for L. So these min problems for cost usually have infinity over infinity endpoints, right? As I make C get a little smaller, I might even do a little drawing here, right? I don't know where these are, but I know it's probably going to look something like this. Just that's the kind of idea. Here's cost, and here's L. Just kind of a thought. And no, you don't have to draw it. If you draw it, though, it's just, it's kind of like you kind of just explain as much reasoning as possible. You draw a little, if you get the perfect number, then, and you explain enough, you're fine. It's just kind of a process about writing enough. And then I'm going to take the derivative and set it equal to 0. All right. So here I've got dc over dw equals, now this is 300 w to the negative 1 plus 300. I could actually simplify this ahead of time. So let's do that ahead of time. I should have simplified this ahead of time. Come here. Let's do that. So this is going to be 600 over W. Watch my math, because I made a nice little math mistake on the video, which inspires great confidence in me. 600 W to the negative 1 plus W plus 1/2 W. Okay. For some reason, I'm getting echo. Okay. Don't know why. Any questions about that? All right. So now I'm going to minimize C. So I do dC over dW equals, okay, so this is going to be negative 1, 6 times 600 W to the negative 2 plus 1 plus 1/2. I could have combined it there. I didn't. This would have been 3/2 W. So that's going to equal 3/2 minus 600 over W squared. And that's going to equal 0. So 1 to 5, how do we feel about that? Just kind of take the derivative. Oops, shoot. Cancel. Polling. Multiple choice. There we go. Take derivative. Set equal to 0. Okay. So after doing that, I wind up with the fact that 600 over W squared equals 3/2, which implies that, so I'm going to multiply W squared over to both sides and divide by 3/2. So I'll get 2/3 times 600. Ooh, that works out nicely. Equals W squared. And that's going to wind up with W squared equaling 400, which implies that 20 equals W. Okay. So 1 to 5, how do we feel about my little getting at what W must be? Okay. Yes, it would be perfectly fine to solve for L first. It does. I pick one and I go, that's my one. All right. So that would have been perfectly fine. And you could even make a little chart if you want to. And that's a good idea. If you want to make a little chart of your variables, this is what it would look like. Right. So I've got kind of area, the area going on here. But notice I don't do this until after I've kind of reasoned the problem. All right. Because I don't want to assign variables to each one of these. I could, but you know, it would not, it would just complicate matters. L is the length. W is the width. Let's see, this moves. And what I'm going to do is I'm going to pick W to drive. It doesn't actually matter which one drives. And then C, which is cost, moves. All right, I can do that. Sometimes these things have fixed things. Most of the time not, but they can. So I just kind of sub in here and I get these like things. So if you feel like doing a list of variables, by all means, it's more data. And then what I'm going to get is, and then I solve for L and I get, let's see, W times L. And then I'm just going to solve for L. And that gives me 20 times L equals 300, which implies that L equals, oh, brain, that's 15, isn't it? Yep. Yep. So L equals 15. Now I need to check that I have. So now I want to check for a minimum. Now there's a couple things I could do. I could take a second derivative and see if it's concave up or concave down. I could make an endpoint argument here. I've got one critical point and I've got infinite endpoints, and that's actually enough. Okay, so I could just say I've got infinite endpoints and then point to this chart. I got a lot of options for how to do this. All right, so just pick one. So option one, for checking min. Option one, make endpoint argument. And here, drawing is nice. Option two, take sample first derivative to the left and right. Okay, so I'll do option two right here. Okay, so my endpoint here, this is L. This is C, and this is C prime. I'm going to need one more thing. And then here I'm going to have, this is the point, so this is, I'm sorry, W, because I took the derivative in terms of W. So this is W here. And then when W equals 20, What goes on here and here? I need sample points. Oh, okay. Well, let's see. C prime is 0, so let's do 10 and 30. Why not? So C prime of 10 equals, what is C prime of 10 here? Equals 3 halves minus 600 over 10 squared, which equals, so that's going to be 3 halves over 6. Sorry, this is going to be 3 halves minus 6, right? Because 10 squared is 100. And 3 halves minus 6, I actually don't care what it is. I only care that it's less than 0. So on this side here, I'm negative. And someone's asked me a question, and that's awesome. Give me 1 second here. Hopefully you're not telling me that I totally messed up something. This is going to be 3 halves minus 6 over 9 with an equal sign. And 6 over 9 is smaller than 3. Yes, so this is 2/3, right? So this is bigger. 3 halves is bigger than 2/3. So that's greater than 0. So that's plus. So here I'm decreasing. Here I'm increasing. Here I have a min. Okay. Yes, so someone's asked in chat. So there's 2 questions in chat that's going on. What happens if I switched around my L and my W on the picture? That's fine. X and Y could be, you're not talking about switching X and Y in the graph. You're talking about switching which one of these is X and which one of these is Y. I don't like to use X and Y on sides of things for this reason. I like to use width, W, height, if I've got something 3-dimensional, radius, if it's like a cylinder or something. I don't like using X and Y. And one of the peer leading packet on Friday is going to use X and Y. And I just like, every time I see that, I'm like, no, you don't want to do that because then you confuse your graph. So I prefer to use symbols other than X and Y. You could use W down here and have a graph that looks like that, and that's perfectly fine. And then you could use this as L and that as W. As long as you make a little thing and label it, right? As long as you make whatever, as long as your picture is labeled, it doesn't matter which one's which. Because it's, hence the thing. And someone's saying, never mind, disregard me. I wasn't like criticizing your thing. I knew what you kind of meant. I was just like, I was just kind of trying to say a clarification thing. Okay. So how do we feel about this idea of checking for an endpoint 1 to 5? I'm sorry, not checking for an endpoint. Talking about this, checking for the min. Okay. I'm going to regret doing this, but I'm going to do it anyway. The other way to do it is to take to do a second derivative test. So option 3. Take second derivative and talk about concavity. Okay? So what I want to do is, I'll take, so if I wanted to do this option 3, this is what it would look like. And a lot of times this is the fastest way to do it. It's not because you get the sign of the derivative very, very quickly. So, sometimes this is the fastest way to do it. I personally think the endpoint argument's the fastest. But it only works if you only have one critical value, because you have to actually find them all for the critical values. But if you have one critical value, I find that's the fastest. But let's go ahead and do this second derivative test. So I've got 3 halves. This should be of W. So I've got the derivative with respect to W of 3 halves minus 600 over w squared. And this 600 over w squared is really w to the negative 2. Now, the reason why this can be really fast is usually the sign of this thing is obvious. So watch this. So this bit goes to 0. And so this here is going to become, so this is going to be 0 minus the quantity, minus 2 times 600 w to the negative 3. Now, I actually don't care about, I don't care what the numbers are. I care about only the sign. Okay? So I've got here this 0, that's fine. Those negatives are going to cancel here. So I'm going to get 2 times 600 over w cubed. And remember, I only care about the sign. I don't care about the actual number. So I don't need to multiply this out. I don't care. The only thing I care about is that c double prime of 20, right? If I plug this in here, I'm going to get 2 times 600 over 20 cubed, and I don't care about anything except the fact that's greater than 0. So C is concave up, and I have a min. 1 to 5, how do we feel about that second derivative trick? And the reason why it's really nice is that it's fast. This tells me, because it's concave up, right? It tells me this. Right? It tells me I've got a min. You can look at this and go, oh, look, I've got a min. Why? Because I'm decreasing and increasing. How do I know? I'm concave up. Now, I don't encourage this as a normal tactic for these types of problems. I highly encourage either a first derivative test or an endpoint check. And I especially encourage the endpoint check because sometimes there are problems, and you'll have one on a future quiz and or the problem set next week, where you have endpoints that, you have a tree in the way or a fire hydrant. Okay? So that's why I encourage those endpoint checks, because that makes it just like the problems you've already done. But I'm saying you could do this if you desired. And it's kind of a clever trick, and it'll serve you well in Calc 3 if you remember how to do it. All right, so if you're moving on with life after this, that second derivative trick is going to make you a little happy. Okay, so the next thing I need to do is put it all together. Okay, so my least expensive option will be L equals 15 feet, W equals 20 feet, where where W is the side. And then here, everything after this is just gravy, where W is the length of the north fence. Right? So I say something like that. I can't spell. Where W is the length of the north fence, it will cost... I didn't actually put it together. I could solve for what C is, but notice here it didn't actually ask me that. Notice here it asked me how many feet of thin fence and how many feet of chain length fence should be used. Notice what it asked. So what is the least expensive way to set up the parking lot? And then how many feet? Okay. Use 30 feet of themed fence. I'm sorry, 30 plus 20. Use 2 times 15 plus 20 equals 50 feet of chain fence. I'm sorry, of themed fence. And I spelled fence wrong several times here. And 30 and 20 feet of chain link. Okay. How do we feel about that kind of putting it all together kind of thing, 1 to 5? Remember that what I have is length times width. That's a very good question. So the question is, isn't W only half of the north fence? No. W is the length of the north fence, right? And L is the length of the themed fence on this side, right? So I can think of W as the length of the north fence and L as the length of the east fence or the west fence. Okay, so I what I've got here is W times L. So when I do this, that means I've got two. These L's are themed fence, and so is one of the W's. So I've got 2 times 15, or 15 plus 20 of the themed fence, and then I've got 20 as the length of that fence. But notice that 20 is longer than L. Okay. And that's confusing. I'm not saying it's not confusing. It's weird because those aren't my variable names. I could make them my variable names, right? I could, like, if I wanted to, okay? If you wanted to do that, right? You could say, this is an aside. Okay, so if you wanted to assign variable names to everything, I would do this. I do T equals W, L plus W. And chain length, I'll call that H, right? So themed and chain equals W. I could do that. That is totally variable. And then C equals 1/2 H plus T. And then I make the subs into my cost equation, and I get C equals 1/2 W. That's great. I did 1 over W. Equals W over 2 plus L plus W. That is legal. Okay, I'm not saying that's not legal. I think it's got too many variables running around, but if that makes you happy, that makes you happy. And I don't want to... One of the problems, unlike the related rates problems, it's kind of harder to give a recipe because certain things make sense to different people and what they want to do and what they can get away with. So unfortunately, I'm a little less... You must do it this way, right? Because on related rates problems, I could be like, boom, 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 row, you bastards. And on this one, I'm kind of, I kind of have to be a little bit loosey-goosey because different things make sense to different people. Now, the next week's problem set is all going to be about optimization. So you're going to be talking about optimization on Friday. You're going to be talking about, and then on Thursday's lecture, we're going to actually do the derivatives and shapes of graph sections, which is the thing that this problem set and the last 2 problem sets have been about. And then we're going to come back to optimization on Monday and do more optimization problems. And we're going to be doing optimization problems on next week's problem set. So you are going to have lots of optimization problems. I don't want to give you, but and one of those things is going to be you make the steps that work for you. But that's the problem. All these steps work differently for different people. And some of them, if you look in the book, and I know you guys don't have textbooks, most of you just have the ebooks. So if you pull up the ebook, which I don't want to do because I'm broadcasting on Twitch here and I want to post it publicly to YouTube later. But if you pull up the ebook and turn to section 4.5, which is this optimization section, you'll actually see that if you flip to some of the problems that aren't assigned, you've got all these things that are like physics problems, because optimization has a lot of applications. And the hardest part of those problems is figuring out what to label what. And that seems to be, there's this kind of abstract reasoning thing that we just kind of throw you into. What to label what. The most I can do for that is coach you. I can't really teach you. I have to coach you. So you have to come to me with questions on these. So how do you feel about that kind of 1 to 5? That if you feel confused with these, just watching the videos is not going to help. You need to come to me with questions. So this is kind of a coaching situation. Okay, so I don't want to, that's kind of what this is. Optimization is a coaching situation. You're going to have to come to me with questions. Because all of these problems are a little bit different. And in order to get the knack of them, I can't just, and this is one of the problems with having 50 people and one of the problems with remote. You kind of have to talk to me or talk to a tutor, but it really is a coaching problem. You've got to, I can't, we got to fix your swing. It's not, I can give you a video on principles of how to swing a baseball bat. I can give you a video on principles how to throw a baseball. But at the end of the day, someone's got to sit down with you and kind of, this is how you do it. Working in teams works great on these, where you kind of play off each other's strengths and figure it out. So I don't want to scare you about these problems. They are doable. And they will let you math through your econ classes and a bunch of your other classes. Right? I was sitting there in advanced price theory. I couldn't remember anything about it. And I'm sitting here, well, what would happen if the firm minimized its costs? I was like, oh, okay. Let's see. If I take a derivative and set it equal to 0, which is not the way you're supposed to do it. You're supposed to set average cost equal to marginal cost. And, they give you all these things. I never remember how to do that. I took the cost function, I took the derivative, I set it equal to 0. There's the min. I kind of math my way without paying any attention in econ. You can do that. All right, let's talk about this problem here. All right, this is another one of those graphs. One of the things to watch out for, and I don't have any control over this, I hate it when they do this, but note here that there's an extra condition. There's a 9th condition in this graph. Okay, so 1 to 5, how do we feel about the fact that they buried a condition in the question? I personally hate this with a fiery passion, but they can do that to you. So watch it. Okay. So I kind of had this buried condition. Okay. And they can do that to you. They can have differentiable function. I don't like it. I hate it, but they've done it before. And I have less control this semester than I did last semester. And you guys are still raping and pillaging the test. So, you know, I can only... They won't sympathize with me because you guys are doing well on the test. So, you know, there's only so much whining I can do during the test meeting about these things because you guys basically pummeled the test. And there's nothing, you know, they don't want to hear me listen. They don't want to listen to me whine because they all hate me. What can I do? You guys are good. So, you know, there's only so much, you know, yelling I can do about the test. Before they say, Scott, shut up! Oh, you do have your test scores back, by the way. They're on Gradescope. You should have gotten an email saying they were there. All right, so this is negative infinity, -3. So I go over here and I go down to -3. There's that one. F prime of x is less than 0 for everything between -2 and 0. So what I'm going to do here is I'm going to come down here and I'm going to do this. F is concave down on -3, 0. Here to here, I'm going to have concave, 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 concave down. F prime of 1 does not exist. I've got continuity. I need a kink. The limit as I go to infinity is infinity. Okay, this one's tricky. This says F double prime, there should be an X here, equals 0 on 1, 3. That means it's a line. Okay, 1 to 5, how do we feel about that condition? It's a line. And this means concave down. So I've got concave down on 3 infinity. All right. So 1 to 5, how do you feel about my interpretations of these conditions? Okay. All right. Now, there's a tricky one here. This concave down. We usually think of concave down as a hump, but here I've got it going off to infinity. That's going to be tricky. All right, but it's doable. Here I've got, there's no condition from here to here. I've got concave down here and decreasing here. Here I've got 2 conditions at the same time. Let me deal with that. So if I go left to right, I want concave down here. And I've got these kind of 2 conditions here. So I'm going to do this. And that solves that problem. Something like this. Now I need a kink and a line. Come here. It won't move. There it goes. Come on. Twist. Twist and shout, baby, here. All right. Let's do a kink in a line. Oops. And now here's the hard one. I need concave down, but going off to infinity. So what I'm going to do is I'm going to do something like this. And then I'm going to get rid of that up there. Okay. Isn't there an inflection point at 1-3? Ah, no, I'll talk about that in a minute. Okay. All right. So 1 to 5, how do we feel about that? The way that I solved this last condition, where it went off to infinity, but it had this, this last condition. 1 to 5. So let's see. End that poll, start that one. Okay. So let's look at other graphs that do this. Can you guys give me examples of graphs where it goes off to infinity, is always increasing, but is concave down? Okay. So there are a couple of these that are really good to keep in mind. I've got concave down. I've got the tangent lines always run above the graph, but I'm concave down. Right, I'm sorry. The tangent lines always run above the graph, but I still go off to infinity. ln of x. So someone's saying ln of x. That is definitely what. So let's look at some of these functions. If I do, let's see. Screen 2. Perfect. If I do ln of x, you see how this function is concave down, but it still makes it to infinity? It just makes it to infinity very, very slowly. Another example of that is, let's talk about like the square root of x. You see how the square root of x has the exact same behavior? It goes off to infinity, but all of the tangent lines run above it. Okay. So the purpose of this problem is to break your thought that concave down means it has to go like this, right? It doesn't always have to look like negative x squared. You can't have things that meet the definition but go off like this. Okay? So 1 to 5, how do we feel about that? Now, last conduction. This idea of concave down, but off to infinity. Increasing always, but concave down. Right? And your good examples are ln of x, square root of x, any x to anything less than 1, right? If I do x to the 0.2, I'm going to have the exact same kind of behavior. Okay, now let's talk about this line business. I want the second derivative to be 0. So the first thing that's tricky about here is the fact that this says f double prime equals 0 on, right? The thing that's buried here is this. Now remember, I like to use these. This is why I like to use these brackets, right? I like the angled brackets because that says point. This, for me, says interval. But the key word here that you know you have an interval is that word on. Okay? Which is different than the word at. And it's such a huge difference buried in such a small, stupid space. Okay? So 1 to 5, how do we feel about the difference between on and at? And I'm asking these questions because these are the stupid, after the last test, I've come to the conclusion that things can be asked that in a weird way that are distracting and kind of silly. So that's what I'm doing. I'm kind of, asking distracting silliness because I think it can be there. Okay. There's this difference between on and at. On means interval, at means point. That's also why I do the angled brackets. And if I get an opportunity and it has a confusing thing like this, I'm going to try to get a hold of the test ahead of time and then give you a version with angle brackets. Because I hate that. That just pisses me off. But that's what that means. On is this thing where I have an interval. So the way that I get something that's on is that. Now let's check my conditions. Let's just make sure I did everything right. Do I have an infinity? Yes. So I'm going to do a little labeling here. I'm going to make it clear that I go off to negative 3 there. I'm just going to do a little labeling for the asymptote there. F is increasing on negative infinity 2. Yep, that's true. I'll put a little local max. Local max at x equals 2. Just in case the grader's like, well, are you just over to the left a little? The person who grades that question, Laura, would never do that to you. But, I'm just trying to, keep ahead of the thing. But Laura would never do that to you. If you drew something that was just a little bit off, she'd be like, yeah, that's fine. Because she's the best. F prime of x is less than 0 means that this is decreasing from negative 2 to 0. Yes, that's true, right? I'm decreasing from negative 2 to 0. Am I concave down from negative 3 to 0? So if I come here at negative 3, all my tangent lines are running over. Yes. F prime of 1 doesn't exist. True. It's got a kink. The limit as I go to x goes to infinity is that F double prime of 0 on negative infinity. So this is a line from 1 to 3. That's what that means. And this is concave down. Okay. All right, so how do we feel about that 1 to 5? All right. I'll try to get you some more graphing problems then, see if we can help you get more of those. Okay. As usual, I've talked way too much in your session. So let's talk about I do want to say one thing here. So I'm going to get out of Twitch now. And I want to say one thing about the problem set.